Hello everyone, welcome to the session. So first of all, this is an interesting puzzle that came out in the Google handle in one of the Facebook posts. An interesting puzzle. I took a jibe at it a couple of years ago. This is actually called the hardest easy geometry problem. More than problem, this is like a puzzle. Okay. I'll give you a detailed explanation on this one. There are so many YouTube videos out there. You can also go and check it out if you feel like. But again, from the perspective of an aptitude test, is this relevant for CAT? I don't think so. Uh, but then again, we're just doing it for the fun of it. Okay. First of all, let's look into this thing. Let's zoom in a bit so that we can see the things clearly. So what I have done is I've just, tried to zoom in as much as I can. Now, there are a couple of things that I want you to pay attention to. We will be using the idea of triangles a little bit so that, things get easier for us to predict. The first thing that I will ask you to appreciate is that you don't really need to put in any solid geometry understanding into this thing. We will be very easily proving this thing with the help of symmetry. But because this is a puzzle, I would like to give you this idea at the very onset. The puzzle itself has a lot of symmetries. In these type of questions, obviously you can see that this length is 80, or let me say ACB as 80 and ABC as 80 degrees. So 80 degree makes the entire triangle into an isosceles triangle. The trick to this question is that we will try to find out or design an equilateral triangle inside this figure. So symmetry inside symmetry. And if you are able to make the equilateral triangle, things will become very, very easy for you to deduce. Okay. Let's start with the deduction. The very first thing, because it has been given that angle ACB is 80 degree and angle ABC is also 80 degree. One thing that I will do is I would like to drop a perpendicular, let's say not a perpendicular, drop a line from B on this C. So first of all, let me make the line decent. Yeah, so it looks decent. It'll serve our purpose. This is just so that you would appreciate that this is 80 degree. Now, why is this 80 degree? I have purposefully designed this length, let's call this length as CD length, as equal to the length BC, because I want to make sure that these angles rather, this angle and this angle is equal. Again, I am not forcefully putting in numbers. I'm just trying to create a symmetry. And this should tell you that this length and this length is equal. Equal angle subtend equal side, or equal side subtend equal angle. This is a property of the triangle. What basically does is that instead of this 60 degree, now angle CBA is broken down into 20 degrees and 40 degrees. Interesting. Let's see how we can maneuver from there. Okay. Couple of more construction is needed, because obviously I have told you at the very beginning that we will be looking out for that equilateral triangle. So let's see how we can design that equilateral triangle. Obviously the hint is that the equilateral triangle will have an internal angle of 60 degrees. So obviously I can see a 60 degree over there. You could have said, sir, this triangle already has a 60 degree, but then that is a googly. You have to design the equilateral triangle inside the puzzle and not take from external help. Anyways, so what I can very much see is that this is 100 degrees. Now pause for a while. Okay, this is 100 degrees, this is 40 degrees, and I am looking at the triangle. Let me highlight the triangle for you so that you can visualize the triangle very well. I am looking at this triangle. Okay, one of the angle is 100, the other one is 40. Can you tell me this angle? Obviously this is 40, because the sum of all the angles of a triangle is 180 degrees, right? 40 is 80 plus 100 is this thing, 180. Now that's it. Okay, now one more thing I want to do. I know that this is 80 plus 30, that is 110 degrees. Okay, so if this thing has to add up, this has to add up to 70 degrees, this angle. Okay, that also tells me that this is also 70 degrees. Now 40 70 plus 40 is 110. That means this is also 70 degrees. Now, ideally, at this point, you should have told me that, okay, sir, instead of, visualizing it like this, you could have also seen that this triangle can also be taken as that isosceles triangle. Okay. So which triangle? Let me name the, it is not relevant, but let's name them. So this is, let's call this point as G point. Okay, so let's call this as G and let's call this point as H. Okay. All right, so 70 and 70. So we already have a 60 over there. I have a 70 over there, so I can't really make anything with it. So let's see, can I make some other constructions? Let's see. So what I will do is I would like to add this D point to this, let's say this E point. And this has come out to be exactly perfect. Let me see if I can, do this like that. Yeah. All right. Now, obviously, if you just understand what I'm trying to do, I'm just segregating the entire triangle into small areas of isosceles triangles, right? So let's do one more thing. Let us try and understand that this length, because I have already said that this is 60. Can I do something about this length? Okay, before predicting too much, let's do one more thing. Okay, let's use the properties well. So external triangle property, again, which triangle? I'm looking at the triangle BFH. I'll repeat myself. I'm looking at the triangle BFH. BFH mein the external angle is 70. So this has to be equals to 50 degrees. I hope that makes sense, because 50 plus 20 will add up to 70. That is the exterior angle property. Hope that makes sense, right? Now, that basically does my life easier, okay? Because this part, or let me use this color, this part is 50 degrees. Okay, this part is 50 degree. I still have this small little part over there which is not not highlighted. So till the time you figure out how much this small little part will be, let me give you the idea. The idea is that at this point I'm making the equilateral triangle, so I will be looking at this has 10 degrees instead of using, let's say, a line like this. Why not? Let me just make it. Yeah, so I'll just write a 10 degrees over there. That basically means that this angle is 60 degrees, and let me use another color. So this angle is 40 degrees. Oh wow, so I'm again getting an isosceles triangle. This is 40, this is 40, making, so this angle will be 100 degrees. This angle is 100 degrees, vertically opposite angle. This is 70, so this will also be 70. So 100 plus 70 is 170, 170 plus 10 is 180. So this basically, there is no problem in there. Okay. Great. What else can I do? Ultimately I need to calculate for X. Let's see if I can calculate for X. So now that I know that this is 60, this length is 70. Can you predict that this is how much? Please tell me. Please predict. Make the predictions clear. Prediction. Okay. The entire length has to be, again, I'm using the same idea. I'm using the idea of isosceles triangles. And because one of the angles is 70, this angle is 70. Okay. So this entire angle has to be 70. The chotu angle, the small angle, is already 10 degrees. So this has to be a 60 degrees. Now, if this is a 60 degrees, please tell me this has to be an 80 degree, because the linear pair 180 degree. So 60 and 80 is 140. So X comes out to be 40 degrees. So this is the answer to this question. Again, I think this is not the type of a question that will, make you feel, wow, this is a puzzle. This is not a geometry question. And this puzzle can only be solved if you're already aware that you have to design an equilateral triangle inside the figure. And why is that so? Because this is a symmetrical, this thing. This is designed as the hardest easy problem. Okay, so it's not going to be the easiest way to solve this one, right? I hope this made sense. If it did, you know the drill. You have to like the video and you have to subscribe to the channel. That's it. Thank you.